Now, which is very important, which is the part which is very important is steps in radiography testing. The first one is the surface preparation and positioning. Clean the surface to remove dirt, oil, or coating, which is very obvious. Okay, position the component between the radiation source and the detector. So we must have to place at a particular, dedicated place, so that we can have a proper incidence of rays on the material, and after reflection the rays will go other side, and that must be reflecting over the detector, so that the detector can detect all the rays. So for that we must have a specific place inside our lab, okay, so that we can keep that material or component in particular that position, so that we can have a proper incidence of the X-rays and reflection. After reflection, the reflected rays must be incidenting over the detector, so that detector can detect easily and can manipulate or can show you the film, okay, in digital imaging. Step second is radiation exposures. We need to adjust the X-rays or gamma rays intensity based on the material thickness. If material thickness is very less, then we can use the X-ray, and if we are having the high thickness, then we can use the gamma rays. And what frequency that we require, it will be depend on the material as well. Okay, ensure the proper exposure time for the clean imaging. Okay, if you have just not given sufficient time for that X-rays or gamma rays to incident over the material, and after that they reflect over the detector, then it may not show you the correct film of your or correct defect of your product. So so that we must have to provide a sufficient amount of time for gamma rays or whatever the rays that we are using. Okay, that ray must be for sufficient time, so that the picture must be clear. The film, or the third one is the film or digital imaging processing. Okay, so if using the traditional film process, it is the you know dark room with the chemicals, and if we are using digital radiography, capture the enhance the images using the software. These are the this process is being used very frequently, and it was earlier having very popular. Now the fourth step is they detect the interpretations. They analyze the radiography images for dark spots, the low density defects, or the light areas, high density inclusion where we don't have basically defects. Measure the defects size, shape, and positions using the image contrast and differences standards. Step fifth, the documentation and reporting. The same thing. We must have to record the finding, whatever the finding that we are having. We must have to, make a documentation of that, so that we can send to the quality assurance or quality department. They can take a corrective action for that. Okay, capture the result with the industry standards. These are the standards for that. According to that, we must have to compare the result. I mean, what is the result that we are getting for our product? If they are matching with the these all industry standard, then it's okay. Otherwise, we must have to keep send the feedbacks.